We're going to quickly talk about functions of a complex variable. And suppose z is a complex number, or z is a complex variable. We say that f of z is a function of z. If f of z takes a unique value for a given z. In other words, for one value of z, you cannot have two different values of f of z. If that's the case, you have only one value of f of z for a given z, then we say that f of z is a function of a complex variable. So there are many, I'll give you a few examples of functions that you may have seen before. So for example, the magnitude of the complex number z is a function of z, because for example, if you have z is 2 plus 3i, then this function is simply square root of 4 plus 9, which is square root of 13. So that's just a fixed value. And remember, when we take square roots, when we talk about magnitudes, we're always defining it to be just the positive value of the square root. So then it takes a unique value. So another one could be the angle of z, or the argument of z, right? So that would of course be, in this case, the inverse tangent of 3 over 2, but since 2 plus 3i lies in the first quadrant, the value that lies between 0 and pi over 2. So the theta that lies between 0 and pi over 2, since we define it that way, so that's a unique value for every value of z, right? On other examples, so you can have z to the n, where n is an integer. So 1, 2, 3, so on and so forth. And these are all functions because, if we say n is 2, for example, if f of z is z squared, then if I take f of 1 plus 2i, that is simply 1 plus 2i squared, and that's a unique complex number, right? You can evaluate it, and that's just going to give you some number. However, when n is not an integer, f of z is not a function, right? So for example, when n is, let's say, 1/3, then f of z is equal to z raised to n, which is z raised to 1/3. We have already seen that there are three values such that when you take them to power 3 will give you any given value of z. So z raised to 1/3 is not a unique value. So by itself, it's not really a function. If you want to make it a function, we have to define one of these three values as the principal value. And typically what you can do is you can simply define the one for which you are not adding any integer power of 2 pi to the exponent as the principal value. In that case, you can make that as a function, but you would have to make it explicit and say that you're looking at the principal value. Okay. Now, there is one particular function which repeatedly comes in the course, and that is the function e to the z, where z is a complex number. So suppose z is the complex number given by sigma plus j omega, let's say. So the real part is sigma and the imaginary part is omega. Then what is e to the z? So f of z is equal to e to the z is given by e to the sigma plus j omega, which you can write as e to the sigma times e to the j omega. Now, sigma is a real number, e to the sigma is some real number. And e to the j omega, we can interpret that using Euler's formula and write that as cosine omega plus j times sine omega. So f of z in this case would then be e to the sigma times cosine omega plus j sine omega. So that's just another complex number, which is In Cartesian form, it is just e to the sigma cosine omega plus j times e to the sigma sine omega. Okay, so this is a function that you might see a few times in the course.